So, the AI revolution is absolutely booming. We've got new models popping up, it feels like, every single day. But behind all this excitement, there's a massive, hidden traffic jam building up inside the data centers that power everything, and it's costing a fortune. Today, we're going to look at a system called Aegaeon that's designed to blow that traffic jam wide open.
First, let's just get a sense of the scale here. If you go on a platform like Hugging Face, you'll find over 1 million different AI models. 1 million. This gives developers this incredible toolbox, right? You've got everything from these giant, do-it-all models to tiny, super specialized ones. The choice is just amazing.
But, and there's always a but, here's the real question. What's the hidden price tag for all this amazing variety? Because it turns out when you try to actually run thousands of these different models at the same time, you smash headfirst into a huge, and I mean very expensive problem.
And this is what the experts are calling the million model problem. It's one of those classic situations where having more options creates a ton more complexity. And in the world of AI infrastructure, that complexity means one thing: waste. Lots and lots of waste.
Okay, so this chart right here, this is based on real-world data from Alibaba, and it tells the whole story perfectly. Take a look at that huge bar on the left. That represents over 94% of all their models, the vast majority of them, and they get used very, very rarely. Now look at the bar on the right. Even though they're hardly ever used, those models are hogging a whopping 17.7% of all the super expensive GPUs, just sitting around, waiting.
Let me put it another way. Having a powerful electricity-guzzling GPU dedicated to one of these long-tail models, it's like booking an entire 5-star restaurant, just in case one person decides to pop in for a glass of water. It's just a fundamentally broken and incredibly inefficient way to do things.
All right, so the obvious question is, why not just share the GPUs more efficiently? Well, people have definitely tried. The problem is all the old solutions end up creating brand new, and sometimes even worse, problems.
So the two main approaches have been, multiplexing and autoscaling. With multiplexing, you try to cram 2 or 3 models onto one GPU, but you hit a memory wall, fast. Then there's autoscaling, which is a bit smarter. It swaps models in and out as needed, but the swapping process itself, it's just way, way too slow to be practical for a live service.
And both of these old fixes crash and burn because of a classic computer science problem that becomes the main villain of our story. It's called head-of-line blocking. You know what this is? It's when you're in a line and the one person at the very front has some huge, complicated issue, and everyone else behind them is stuck, even if they just have a super quick question.
And here's exactly what that looks like. A request comes in from Model A, and it's a big one that's going to take a while. While the GPU is chugging away on that, new requests come in from Model B and Model C. But guess what? They just have to sit there and wait. It doesn't matter if their request would take a millisecond. They're stuck in traffic behind Model A until it is completely 100% finished.
This is where the big aha moment happens. The researchers behind Aegaeon realized everyone was thinking about the problem on the wrong level. Instead of trying to manage entire requests, what if you could manage every single word, or as it's called, every single token being generated?
So remember this mess, right? It's a single file line, a traffic jam. Model B and Model C are completely stopped, just waiting for Model A to get out of the way. It's slow, it's inefficient, and it's a terrible experience for the user. Now, look at this. Aegaeon's solution is just brilliant. It becomes this master multitasker. Instead of letting Model A finish its entire long job, the system generates just a few tokens for A, then bam, it instantly swaps to B, generates a few tokens, then bam, swaps to C, generates a few tokens, and then it cycles right back around. Everybody makes progress at the same time. The traffic jam just vanishes.
And this technique has a name: token-level autoscaling. It's such a fine-grained, precise way of sharing the GPU, literally switching models in the tiny gaps between words being generated, that it basically allows multiple models to run at the same time, completely eliminating that nasty head-of-line blocking.
Now, that idea is fantastic, right? But making it fast enough to actually work in the real world, well, that takes some serious engineering magic under the hood. So let's see how they pulled it off.
Aegaeon uses 3 main tricks to make this ridiculously fast switching possible. First, it reuses common software parts between models. Second, it manages the GPU's memory directly to cut out any waste. And third, it has a super fast way to sync up each model's short-term memory, what's known as the KV cache.
And the results of those tricks are just wow. Look at this chart. A normal auto-scaling process wastes almost all of its time on overhead, just getting ready to do the work. Aegaeon, on the other hand, pretty much gets rid of all that wasted time, turning this clunky, slow process into something that happens in the blink of an eye.
The final reduction in all that wasteful overhead? A staggering 97%. That's the secret sauce. That's what makes this whole token-level switching idea not just possible, but incredibly powerful.
Okay, so we have this brilliant idea, and we have the clever engineering to make it a reality. But what does this actually mean for the real world? At the end of the day, what is the big payoff?
This quote comes straight from the paper, from when they tested this at Alibaba Cloud. And honestly, the results are absolutely jaw-dropping.
Before Aegaeon to serve all those rarely used models, they needed almost 1,200 GPUs.
After they switched on Aegaeon, they could provide the exact same level of service with just over 200.
That is an 82% reduction in the number of GPUs, an 82% savings on some of the most expensive, power-hungry pieces of computer hardware on the entire planet.
And it's not just about saving hardware. This table shows how that incredible efficiency translates into raw performance. Aegaeon can handle up to 2.5 times more requests than its competitors. That means better, faster service for way more users, all on the same hardware. And that really brings us to the most important takeaway here. This isn't just a cool engineering trick. It fundamentally changes the entire economic equation of AI. So the big question I want to leave you with is this. If we can suddenly run the entire AI revolution on 82% fewer resources, what new ideas, what new companies, what incredible innovations will suddenly become possible?